Okay, so we're going to have a look at the other reactions of alcohols in this video. So I've covered oxidation in another, but I'm going to cover combustion, dehydration and substitution in this one. So first one being combustion. So as we know, combustion is where we react it with oxygen. Or burn it with oxygen. So combustion of alcohols is quite a desirable reaction to do because it tends to be quite a flammable substance, and it also releases quite a lot of energy. So in terms of reactions, we can do the reactions for the combustion of any alcohol. So if I have ethanol over here, it's a liquid, so most alcohols are liquids. If I react that with oxygen gas, in terms of what they produce the same thing as burning a hydrocarbon. So we are going to produce, if we're doing the complete combustion, we are going to produce water and CO2, so water liquid and carbon dioxide gas. Okay, so all we then need to do is balance this equation like so. So this is the complete combustion of ethanol. We're still forming water and carbon dioxide like we would with a hydrocarbon. We can also do the incomplete combustion if we wanted to, and that would be where we form carbon monoxide and water. Okay, so that's fairly straightforward. They just do the same thing that the hydrocarbons do. Right, so let's now have a look at the dehydration reaction of alcohols. So hydration is where we add water. Dehydration is where we're going to remove water. So we're going to start off with our alcohol. I'm just going to go for ethanol. Okay, and what I'm going to do is I'm going to heat it. So if I heat it, it's usually reflux, you can write heat as well. And I'm going to use phosphoric acid as my catalyst. And what I'm going to do is I'm going to remove water. So I'm going to remove a water molecule. So water is H2O. So I'm going to remove the OH. And I've got to remove a hydrogen on the carbon next to it. So these two carbons here, I'm going to remove OH from here and H from here. And what that does is it reforms that double bond between them. Okay, so all I've done is I've removed this OH and this hydrogen, but it's got to be a hydrogen on the neighbouring carbon, and I have formed the alkene that it could have been made from, and I've released a water molecule as well. Okay, so hopefully you can see that this is the reverse of the hydration of an alkene. So the hydration of an alkene is where we have steam with an alkene which forms the alcohols. We can do the reverse of that by heating it under the same conditions to get back that alkene and the water. So we eliminate our water molecule. As you can see, we've actually started off with one reactant and we formed two products. Okay, this is an example of an elimination reaction. So if we have one reactant being broken into two, this is called an elimination reaction. Okay, if we have two reactants going to two products, that's substitution. If we have two reactants going to one product, that's called an addition reaction. Okay, so you need to know what type of reaction it is. In terms of the mechanism, this would be an elimination reaction, or you can call it a dehydration reaction as well, because we're removing water. One thing that's worth noting about this reaction, the dehydration reaction, is which hydrogen we're going to take off. So I'm just going to draw a molecule. So this molecule here, 4 carbons in a chain, OH coming off of 2, so this is butan-2-ol. If I'm going to eliminate water, if I'm going to get rid of water, there's a few options. I've only got 2 options actually. There's 2 options I can do. So I've got to remove this OH, okay, but I can either remove So it's got to be off of the adjacent carbon. So I could either remove this hydrogen or I could remove this hydrogen. Okay, let's go for if I remove these two together to release my water molecule. If I do that, I form the double bond here. So between these two carbons here, I form the double bond. And that's going to give me this molecule here. Plus water. Okay, and this molecule here is called but-1-ene. Okay, so that's one thing that can happen, which is if I remove this water molecule here. The other thing that can happen is I could remove it on the other side. So I could remove this as my water molecule. If I do that, my double bond is then going to be between these two central carbons, and therefore my product would be this. And this over here, sorry, plus water as well. This over here is but-2-ene. Okay, so whenever we do the dehydration of an alcohol, if we've got an asymmetrical alcohol, we are going to form a mixture of two isomers. So in this one, if I do the dehydration of this molecule here, I'm going to form both but-1-ene and but-2-ene, because it could be the hydrogen on this side that's removed or the hydrogen on this side. And that gives me a mixture of products, and those products are going to be stereoisomers of each other. Structural isomers of each other. Okay, so I'm going to have but-1-ene and but-2-ene as well. Right, the other reaction we're going to look at is the substitution reaction. Okay, so substitution means where you usually start off with two reactants and end up with two products. So with an alcohol, what we can do, so let's start off with, let's go for ethanol. A substitution reaction, for this one, I'm literally just going to replace the OH with another functional group. And I'm just going to go for a halogen. So I'm just going to get a halogen and substitute that. So I'm going to go for Br. Okay, so this is, I'm just constructing the overall reaction, the overall equation. Okay, so it's substitution because the OH has been substituted with the Br. We form this halo alkane over here. In order to do this, the other reactant that I need to have is HBr. Okay, obviously if I was doing Cl here, I'd have to have HCl here. If I was going to have I here, I'd have to have HI over here. And then, as you can hopefully see, the other product is going to be water. If we kick out, if this Br kicks out the OH here, we're left with OH and H here, which releases H2O. So this is the overall reaction. In terms of the reaction conditions, we can't actually just use HBr straight. Okay, we have to produce HBr in the test tube. And the way that we do that, so for this one, the way that we would do that is we get sodium bromide and we react it with sulfuric acid. And what that does is it releases HBr and also this sodium hydrogen sulfate compound here. Okay, so this here is technically step 1, and then step 2 occurs. So in step 1, we produce the hydrogen bromide. That hydrogen bromide then takes part in this substitution reaction here. Okay, so in terms of reaction conditions, if you want to do the substitution reaction, you need to have a sodium halide. So obviously, depending on the halogen you want to use, you have a sodium halide, you need to have sulfuric acid, and that is going to release your not your sodium halide, it's going to release your hydrogen halide and sodium hydrogen sulfate. Okay, so in terms of the overall reaction, you are using, so I'm just going to rub this out. In terms of the overall reaction for this, you're reacting this with sodium bromide and sulfuric acid. and you're releasing the haloalkane, and we're producing water, and we're producing sodium hydrogen sulfate. Okay, so sulfuric acid in this case is not acting as a catalyst, it's not regenerated at the end. Okay, it's actually taking part in this reaction. So what I've drawn here is what the overall reaction is. Okay, so we use sodium bromide or sodium halide and sulfuric acid, and we release water and sodium hydrogen halide, sodium hydrogen sulfate in this reaction.